You are welcome again, guys, to another series of video. We're having a math challenge. Just read 27 to the power of x minus x is equal to 0. So we are looking for the value of x in this challenge. So if you are new here, please subscribe, and by the time you subscribe, don't forget to turn on the notification button so that you get notified anytime I drop videos on mathematics. So I can say solution. In order for me to solve this, I can say 27 x minus x is equals to 0. So for me to solve this, I can bring this s to this right hand side, and this is a negative sign. If it's coming this way, it's going to be positive. So I'm going to have 27 to the power of x is equals to x, which I can rewrite to be x is equals to 27 to the power of x. X is equals to 27 to the power of x. Okay, what am I simply going to do from this point? Okay, we're having x as a base number at this left hand side. We're having x as a power number at this right hand side. In order for me to tackle this s and bringing it down, I can multiply both sides with the natural log, which is the ln. So I can say ln of x is equals to ln of 27 to the power of x. Okay, having done this, I can say ln of x is equals to, so this is coming backward. We're going to have x ln of 27. So since we bring this, since we are not having this, what are we simply going to do again? We can divide both sides with x. Divide both sides by x, divide both sides by x. So if I should do that, I'm going to have ln of x over x is equals to ln of 27. So since I'm having this, I can write x to be x is also equals to exponent of ln of what? Of x, because this exponent will cancel off this ln, which is also equals to x. So in the place of x, I'm putting exponent of ln of x. So I'm going to have ln of x over exponent of ln of x is equals to ln 27. So I want to make this a numerator. And if I'm making it into a numerator from the principle of indices, if I'm having 1 all over a is also equals to a to the power of negative 1. So if I should apply this through here, I'm going to have ln of x times exponent of ln of x negative 1 is equals to ln of 27. Okay, we're not having this here, so this will come to the back. So I'm going to have ln of x times exponent of negative ln of what? Of x, because I'm saying I'm bringing this one to the back, which is equals to ln of 27. Okay, this thing is getting more interesting. At this junction, for me to look for the value of x, I'm having ln of x times exponent of negative ln of x is equals to ln 27. In order for us to get the value of x, we have to apply what we call the Lambert W function. The Lambert W function says, if I'm having a to the power of n times exponent of a to the power of n is equals to a to the power of n. That's what the Lambert W function is saying. If you're having a to the power of n times exponent of a to the power of n, if I should take the Lambert W function of it, or let me write it better here, Lambert W function a to the power of n exponent of a to the power of n is equals to a to the power of n. That's what Lambert W function is saying. Okay, coming back to this point, we are having ln of x times exponent of negative ln of x is equals to ln 27. You can see this one, we are having a negative here, but at this base we are not having a negative. So what are we going to do to make this place be negative? We are going to multiply both sides of the equation with negative sign. So we can say negative ln of x times exponent of ln of x is equals to negative ln 27, because this negative sign will cancel off this. So we are not having this. So now we cannot take the Lambert W function of it. So if we should do that, we can say Lambert W function of negative ln of x times exponent of negative ln of x close bracket is equals to the Lambert W function of negative ln of 27. Recall we said if we take the Lambert W function of open bracket a to the power of n times exponent of a to the power of n close bracket is equals to a to the power of n. So if we should apply this through here, we have a negative ln of x is equals to the Lambert W function into negative ln of 27. Negative ln of 27. So let us come here. Let's come here. Coming this way, we are now having negative ln of x is equals to the Lambert W function into negative ln of 27 close the brackets. Close the brackets. Okay, this is what we are now having. Okay, since we are not having this, we are having an ln here. We are having an ln here. Okay, we are having a negative sign here. We can rewrite the whole of this. To be ln of x to the negative 1 equals to the Lambert W function into what? Negative ln of 27 close bracket. So this which I can write, we are now have ln of x to the power of negative 1 is equal to Lambert W function. In order for me to look for the value of x, I can take exponent of both sides. If I should take exponent of both sides, I'm going to have exponent of ln of x to the negative 1 is equals to exponent of Lambert W function into negative ln of 27. Because this exponent will cancel off this exponent and we are returning back to this. So recall I said if we are having exponent of ln of a is also equals to a, because this exponent will cancel off this. So this and this will go. We are now having x to negative 1 is equals to exponent, sorry, I'm writing my exponent somehow, Lambert W function into negative ln of 27 close brackets. So, but this is not the actual value of x, this is an inverse of x. So I can write this again. Recall from the indices rule, we are having a negative to the power of negative 1 is also equals to 1 all over a. So I can say 1 all over x is equals to exponent of w Lambert W function into ln of what? 27. Ln of 27. This is 27. This is 27. And if we should take the inverse of it, our x is equals to 1 over exponent of Lambert W function into negative ln of 27. So this is the value for x. X is equals to 1 all over exponent of Lambert W function into negative ln of 27. So this is the value for x. So if you find this video useful and interesting, please don't forget to turn on the notification button and hit up that subscription button. Thank you very much. I love you and see you in our subsequent video. Bye for now.